Okay. Good morning, everyone. My name is Faizal. I'm Faizal Rohmat. I'm from ITB Indonesia, and I'm here with Joanna and Zul, also with us in the room. So I would like to present about the impact of climate change on urban flooding in Majalaya, Indonesia. And this is part of the research or activity funded by the British Council, University of Greenwich, and University of Indonesia. Next slide, please, for the introduction. Next slide. Okay, so I will start with the study area, which is Majalaya, a small city in Indonesia. It's located in the province of West Java. The city's industry is vital for West Java's and Indonesia's economy. However, it is very prone to flooding from Citarum River. And some of you may have heard about the Citarum River. It's one of the most polluted rivers on Earth. On the next slide, we see Majalaya flood. It's happening at least 6 events every year. And as you can see, it's flooding like 20 centimeters to 100 centimeters. And it is in nationwide. It's an effect of urbanization, and climate change could aggravate a flood vulnerable city. Next slide. So the objective of our study is to develop a flood model based on historical flood, and then to assess Majalaya's spatiotemporal projection of rainfall, and then the last one is to identify future potential follow-up studies. On the next slide, in the model development, we see here the maximum amount of 24 hours rainfall from 2004 through 2019. Even with at least 70 to 90 millimeters of rainfall for 24 hours, it's already flooding at least 6 times every year. And in 2017, we have a drastic increase, and also in 2018, it created severe flood, and even it collapsed the city's infrastructure. And in 2018, it created big disaster, dozens injured, 1 dead, and also dozens of houses destroyed as pictured. On the next slide. Now, for the 2018 February flood, the picture is the crowdsourced extent of flood. To note that there is no official flood extent. It's a challenge in the developing countries. But the local flood watcher community created the flood extent on the day after the flood, which in our case, it's important for the calibration of our models. On the next slide, for the terrain, for the modeling, and also for the modeling stuff, we are using HEC-RAS 6.2. The data source is, first we use drone survey digital surface model with 1 meter resolution, combined with cross-section data. We mesh it together. And also we use calibrated hydrographs using JAXA's GS map, because in our region the data is only available for 24 hours cumulative rainfall. On the next slide is the calibration of the model of the hydrograph. We have one stream gauged, but the other streams are ungauged, so we have to develop a rainfall model. And then the learned parameter is used to model the ungauged streams. On the next slide, and for the climate change due to projections, sorry about my face, we are using CMIP6 to calibrate or to learn about the spatiotemporal variability of rainfall regimes in Majalaya Basin. In bottom line, for the mid-future period and far future period, we will have increasing rainfalls. On the next slide. So these are the results of our simulation. We are actually doing 3 simulations: the 2018 flood, 2017 flood, and 2017 projected flood, and 2100 projected flood. We are only showing 2 of them. So there are agreements and disagreements, as you see on the slide. For example, on the southwest and northeast areas, The model says there is flood, but the report says there was no flood. And this is because the area is a paddy field area, and there were no eyewitnesses at that time. So, but this is a solid argument that we could say, hey, the model says we have a flood risk here, but it's okay because there was no eyewitnesses, because the flood happens at around 9 p.m. through midnight. On the next slide, in the middle area, we have the opposite. The model says no flood, but the eyewitnesses said there was flood, this centimeter, for example, and that is caused by trash clogging. I think this is unique to the eastern part of the world, the southeastern part of the world. And as you can see here, those are actual pictures from the areas in Majalaya. The channels are clogged with trash, and the floodwater community mentioned that before the 2018 flood, people did not really take care about the trash, and after the flood, they had a shift in their mind about trash management, which is a good direction, but actually we're still working on that. So in here, the catch of this model is this HEC-RAS model does not have the capacity to model such a process, such trash clogging process, and this is one of the interesting direction as the follow-up studies. On the next slide. Now we also calculate the flood risk score, and as shown here, there is an increase of flooded area in the built area by 5%, and also for the risk score, it increases by 5.1% as well. Next slide. Yeah, conclusion. Next slide. Okay, so first we have a numerical flood model based on Majalaya's historical flood events. And the numerical model shows explainable agreements and disagreements over the reported flood extent. Again, this is a big challenge in developing countries because we are still working on the official reporting of flood extents. And the next one is the global climate projection results in flooded area will increase the flood area by 5% and risk score by 5.1%. And some of the future potential follow-up studies are first, we could try to develop a network or city-scale channel clogging model, and also a network city-scale socio-ecological coupled model, because trash clogging is not only physical process but also behavioral process. Next, and I would like to acknowledge our sponsors, Indonesia-UK workshop funded by British Council, Greenwich and Universities of Indonesia, and also my own host university. And I'm sorry if I don't have my contact information ready on the slide, but if you Google my name, you know that I'm the Indonesian flag guy. Thank you very much.
Your address should also be visible with the abstract.
Yeah.